Good day, ladies and gents. Welcome to BK Mathematics. And today, let's get to learn. We are going to treat matrices. And this is one of the biggest topics that students normally face in an exam. Let's get to simplify it for everybody to understand. Now, the first thing, let's try to learn what is matrix, and after which we are going to learn the various types of matrix, and perhaps we are going to solve millions of examples and to unlock the trick in which we are going to use to solve matrices. Okay. Now, the first thing, when we say matrices, it means is the rectangular array of arranging numbers. They can either be in a row or in a column form. Now, for instance, if you're having something like this, and this is what I mean, this is what we call matrices. Okay. Now, they can either arrange in a rectangular form. They can also be in a row or in a column form. These two numbers that you are seeing here, they are in a row, and these other numbers 0 and 2, we call them as columns. Okay, and this element that you are seeing inside this matrix, we refer them to be elements. 0 1 2 1, we refer them to be elements. Okay, so it's what we refer to be matrices. Now the next thing, let's just look at the types of matrices. We say types. Let's learn the types of matrices. Now the first type that we are coming to learn here is, we say identity matrix. The first one, we say identity. We say identity matrix. Now, when we talk about identity matrix, we say this is types of matrix that you are going to have one, where in the square of matrix, it is equal to 1. For instance, having something like this is 1 0 0 1. Okay, this is what we call identity matrix. Now, from this point, this one is equal to 1 simply because if you are finding the determinant of this matrix, automatically you are going to have 1. For instance, saying multiplying the diagonal minus non-diagonal, that is, we say 1 times 1 minus non-diagonals, that is 0 times 0. Therefore, multiplying these two numbers, automatically you are going to have 1 minus 0 times 0, we know it is 0. Then subtracting 1 minus 0, you are going to have 1. That is why we call it identity matrix. Okay, there are matrices that are equal to 1. This is the first one among the types of matrix. Let's look at the second one. We say diagonal. We say diagonal matrix. Now, when we say also diagonal matrix, is wherein after the main diagonals, all the other matrices, they are equal to 0. Okay. For instance, having something like this, we have, let's say this is our main diagonals. These are our main diagonals. Now, each other number that you are seeing here might be 0. Let's say this is our 1. We have 0, 2, we have 3. This is 0. This is 0 also. Let's say this is 0. We have this is 0, and this is also 0. This is what we refer to be diagonal matrix. Okay. After the main diagonal, this is our main diagonals. After the main diagonals, the other element that you are seeing, they are equal to 0. This is what we refer to be diagonal matrix. Let's look at null matrix or 0 matrix. When we say null or 0 matrix, this is another type of matrix that we have to learn before we start to solve any examples. We say 0 matrix or null matrix, they are matrices that are equal to 0. All the elements that are seen inside the parentheses or the bracket, they are equal to 0. All the elements. For instance, you can see 0 0. Whenever you are seeing something like this, this is 0 matrix. You can see 3 by 3 matrix is also something like this. We refer them to be 0 matrix because all these elements that you are seeing inside this bracket, they are equal to 0. That is what we refer to be null matrix. Okay. Now let's look at the next one. We say this is the third one among the types of matrix. Let's look at the next one. That is, we say the fourth matrix. We say equal matrix. Let's look at equal matrix. When we say equal matrix, this is wherein all the other parts of the matrix, they are equal to the other side of they are equal to the other parts of the other matrix that you are given. For instance, having something like this, let's say you have something like this. Let's look at this. Now, if you have something like this, we refer this one to be equal matrix because this element, this matrix that you are seeing, is equal to this other matrix. They are the same. That's what we refer them to be equal matrix. Therefore, if you are comparing from this point, we say this is A is equal to, and this C is equal to 1. meaning they are equal to each other. The first matrix is equal to the other matrix, the second one is equal to the second one, the third one is equal to the third one, and this last one, that is D, is equal to 1. We refer them to be an equal matrix. Let's look at upper matrix. Upper matrix. Now when we say upper matrix, this is wherein all the elements below the main diagonals are 0. Yes. For instance, having something like this, let's just write and see. If you have something like this, you have 1, 2, 3. We have 0, 1, 2, and 0, 3, 4. Now after the main diagonals, all the elements that we are seeing, they are equal to 0. For the fact that this is below, after the main diagonal, this is our main diagonals, it means this also should be 0, because according to upper matrix, we say there are matrices that after the main diagonals, all the other elements below this main diagonal, they are 0. So this is what we call upper matrix. Okay. Now the next thing that we have to look here is, let's say this is our 6th type among the types of matrix. We say transpose. Let's say transpose matrix. This is one of the most critical type of matrix that we have to look at. When we say transpose matrix, this is wherein the diagonal is switching to, if you're having the row, is going to switch on to the columns. For instance, having 4, 3, 4, 1. Let's say this is 2. Now we know these two numbers, 4 and 2, they are row, they're in the row forms, and 4 and 3 also, they are in column numbers. Now to find the transpose matrix of A, now we want to find the transpose matrix of A. Now meaning all these rows, we are going to switch them to columns, and the columns we switch them to row. That is, we say this is how we are going to represent it as T, meaning we transpose this T now becomes, we say 4, 2, meaning these numbers, this row then becomes columns, like we are seeing them now, and these columns, this and these other ones becomes the column. That is, we say this one becomes 3, 1. Okay, this is what we refer to be transpose matrix. Okay, we transpose the row to columns and the columns to row. Okay, this is what we refer to be transpose matrix. Okay, the next thing, when we say square matrix, and let's look at it here. This is the 7th type among the types of matrix. We say square matrix. When we say square matrix, and this is wherein the row and the columns having the same numbers of elements in a bracket. They have the same number of row in columns and also in rows. That is, if you have 1, 2, 3, 4, the same number of row here, you know, you have 2 numbers in a row, and also there are 2 numbers in columns. That is for 2 by 2 matrix. Let's take a look at the 3 by 3 matrix. This is 1, 0, 1, 3, 4, 1, 6, 7, 2. The same thing again, you have 3 numbers in a row, and there are 3 numbers also in a column. This is what we call square matrix. Okay, now for the fact that we have learned the various types of matrix and what matrix mean, now let's look at how to solve additional matrix. Okay, let's try to look at additional matrix. Let's look at additional matrix and see. Now additional matrix, let's say this is our next subtopic. We say additional, or you can say addition of matrix. Let's say addition of matrix. Now to add addition of matrix, you must have the same number of row and columns for the first matrix, and also the other matrix that are given, they must have the same number of row and columns. Therefore, you can add them together. For instance, let's say you have matrix A is given as 1, 2, 0, 3, and matrix B is given as 4, 3, 2, 1. Then they will ask you to add. Then let's say this is C. Let's say this is C. Then we have 2, 3, 1, 4. Let's look at this. Maybe I will give you examples on this one. Let's just look at this explanation and see. Now we have to add A plus B. and C plus A. Let's look at this one. If you want to add A plus B, it's very, very simple. We are given the matrix of A and B is also given. Now to add this matrix, we say we are going to add, just like we say A plus B is equals, what is A? We know A is given as 1, 0, 2, 3. Remember, this is square matrix, like I just explained it. We say 1, 2, 0, 3. We say plus. Let's just add the other one. That is B. We have B as 4, 3, 2, 1. Now adding these numbers, we are going to say, let's just add these numbers and see. Let's add these numbers and see. Now adding these two numbers, we are going to have, now from this, we just need to add the corresponding numbers. We add the first number to the first number, the second one with the second one, the third number with the third number. That's how we are going to add them. It's very, very simple. That is why we refer it to be addition of matrix. Then we say 1 plus this next number plus 4. Give a space. That is the next one. We say 0 plus 2. The next one we say 2 plus 3. 2 plus 3. The next two, just give a space also, and we say 3 plus 1. 3 plus 1. Then after which, if you're adding these numbers, automatically you're going to have, we know 1 plus 4, it is 5. We write it. The same thing, 2 plus 3, we know it is 5. We say 0 plus 2, we have 2. 3 plus 1, 4. So therefore, this is our answer for A plus B. We have added the matrix of A and B, which results us to 5, 5, 2, 4. Okay, as our answer. Let's look at the next one. That is C plus A. We apply the same thing again. Let's say we have C plus A. Now, if you want to find C plus A, we say C plus A is equal. The same thing again. We know C, we are giving C matrix as 2, 3. We are giving 2, 3, 1, 4. We just need to add it with A, and we know A is giving us 1, 0, 2, 3. Let's add it and see. Let's add it here. We have 1, 0, 2, 3. The same thing again. We just need to add the first number with the first number, the second one with the second one. That is, we say 2 plus 1. Give a space. Then we move to the next one. We say 1 plus 0. The same thing implies we say 0, 3 plus 2. Then we say 4 plus 3. After which, you just need to add them. Then we say this one becomes 3, 5. 1 plus 0, we know it is 1. 4 plus 3, giving us 7. Therefore, the first matrix that we are asked to find, the second one, that is C plus A, then becomes 3, 1, 5, 7 respectively. So this is what we are asked to find for example 1. Okay, this is example 1 that we are asked to find on addition of matrix. Let's look at example 2 and see also what we are going to have. Now for instance, let's look at example 2 and see what we are going to have also. Now for example 2, let's say we have, let's say this is our example 2. We have solved example 1. Let's look at example 2 and see. Maybe they will say, given that matrix A is given as 2 minus 1, 3, 2, and matrix C is given as 2, 4, 1, 3. Then we also find Roman 1, 2A plus B, Roman 2, C plus A. Let's say C plus 3A. Let's say this is B also. Let's look at this one and see. Let's say this is our example 2. We are given, it reads, given that matrix A is given as 2 minus 1, 3, 2, and C is given as 2, 4, 1, 3, and B, this is matrix B, is given as minus 1, 2, 3, 0. This is what we are given. Then we have to find 2A plus B and C plus 3A. This is what we are given exactly. Now to find this one is very, very simple. Let's start with a solution. The first one that we are given, we have to find 2A plus B. This is very, very simple. Now what I need to do here is, but you are not given 2A. but you are giving matrix A. Now let's use matrix A to multiply it by 2. Then we say this one becomes 2 into, what is A? We know matrix A is giving us 2 minus 1, 3, 2. This is what we are giving, plus we know B is giving us, matrix B is giving us minus 1, 2, 3, 0. Okay, then after which, what I need to do here is we try to multiply. Let's use this 2 to multiply this matrix. Then we have 2 times 2, we are going to have 4. We have 2 minus 1 giving us minus 2. Now we have, let's multiply again and see. 2 times 3, we have 6. 2 times 2 giving us 4. Now we use this 2 to multiply this entire element that are inside this bracket. Plus, we have this minus 1, 2, 3, 0. Now for the fact that we are asked to add these 2 elements, therefore we are going to add them. We say 4. Remember, like what we just solved in example 1, we add the first number with the first number. Therefore we say 4. We know plus times minus, we are going to have negative 1. Leave a space. Then we say 6 plus 3. We say 6 plus 3. Then the next number we are going to say minus 2 plus 2. Then we say 4 plus 0. Now from this point, we just need to add where necessary. Now adding this number, we say 4 minus 1, we are going to have 3. Minus 2 plus 2, it is 0. Then 6 plus 3, we know it is 9. And 4 plus 0, it is 4. Okay, therefore 2a plus b then resulting to 3094 as required. Let's look at Roman 2. Roman 2, we have to find c plus 3a. C plus 3a, we are going to solve the same thing using the same principle as we just did. Okay, now for Roman 2, we are given c plus 3a. We are asked to find c plus 3a. The same thing, we are not given 3a. But like, let's just say to find 3a first. Now we say 3 into, what is a? We know a is giving us 2, negative 1, 3, 2. Then to find this one, we just need to multiply this 3 by the elements inside this bracket. Then if you do, we are going to have 3 times 2 giving you 6. 3 times minus 1, this is minus 3. 3 times 3 giving you 9. 3 times 2 giving you 6. This is 3a. But like we are asked to add c plus 3a. But like we are given c as, we have c as 2, 4, 1, 3 plus we have 3a as 6 minus 3, 9, 6. Let's just add this matrix and see what we are going to have. Then let's add the first number with the first number. We say 2 plus 6. Give a space. Then we consider the second number also. We see 1 plus 9. Then same thing. We say 4 negative 3 because plus times minus, we are going to have minus 3. Then 3 times 3 plus 6. We say 3 plus 6 also. Then this one becomes, let's add and see. 2 plus 6, we know we are going to have 8. Then we say 4 minus 3, we know it is 1. 1 plus 9 giving us 10. And 3 plus 6 giving us 9. So therefore, the matrix C plus 3 that we are asked to find then resulting to 8, 1, 10, 9 as required. This is example 2. Okay, now let's try to move to the next subtopic, that is subtraction of matrices. Let's try to learn how to subtract matrices also, because after addition of matrices, we are going to look at subtraction of matrices. Let's try to look at subtraction of matrices. Okay, it is also simple. It depends if you arrive. Then let's say we are given, this is subtraction of matrices. This is the next topic. We say subtraction of matrices. Now to subtract matrices, like what we are doing, like what we just did in addition of matrices, we subtract the corresponding numbers. That is the first number, we subtract it with the second number. Okay, the first number we are going to subtract with the second number. The second number we subtract with the second number. That's how we are going to do it. Okay, now for instance, let's say example 1, having, let's say given that matrix M is given as 0, 2 minus 1, 3, and matrix N is given as 2, 1, 3, 2. Okay, then we have to find, let's say we have to find m minus n, that is Roman 1, and Roman 2, we have to find n minus m. Automatically, whenever you are seeing this sign, it tells us that we have to subtract the two matrices that we are given. For instance, we just need to say solution. Now, for the fact that we have to find m minus n, but like we are given m matrix as 0, 2, minus 1, 3, negative, that is this sign is this, and n matrix we are given n matrix as 2, 1, 3, 2. Okay, now to subtract this one, what I need to do here is we subtract the corresponding numbers. Okay, we say 0 minus 2, like what we just did in addition of matrix. We add the corresponding terms. Here we just need to subtract the corresponding numbers. That is, we say 0 minus 2 for the first one, leave a space, then we say negative 1 minus 3, then we consider also this one. We say 2 negative 1, okay, 3 minus 2 also. Okay, now simplifying this one, you are going to have, let's say this one becomes 0 minus 2, we know it is negative 2, 2 minus 1, it is 1, and we have minus 1 minus 3, you are going to have negative 4, and 3 minus 2 giving you 1. So this is what we have to find for Roman 1, finding m minus n. Our answer then becomes negative 2, 1, negative 4, and 1. This is what we have to find for Roman 1. Let's look at Roman 2. Roman 2, we have to find m minus n. M minus n, it is the same thing again. Let's try to look at it and see. Now to find m and n, we are going to have, we say n minus m, this one is equal, but like remember, we are given n matrix as this and m also is given. We just need to substitute them. N is given as 2, 1, 3, 2. Okay, negative, we know m is also given as 0, 2, negative 1, and 3. We write them also. Say 0, 2, negative 1, and 3. Then after which we subtract the corresponding terms like what we just did in a Roman 1. Okay, then we say this one becomes 2 minus 0, that is the first one with the first one, then leave a space, we subtract also the second one. We say 3 negative minus, that is this is the point where most of you guys made a mistake. Whenever you multiply the same sign, you're going to have plus. We say minus minus, we know it is plus for basic identity. Then we write 1, this one. The same thing again, we say 1 minus 2. Say 1 minus 2. Leave a space, then we consider the next number also. We say 2 minus 3. We say 2 minus 3. Then after which we subtract now, or we add where necessary. 2 minus 0, it is 2. 1 minus 2, giving you negative 1. 3 plus 1, it is 4. 2 minus 3, giving us negative 1. Therefore, we say n minus m that we have to find then becomes 2 negative 1, 4 negative 1 also as required. This is what we have to find for example 1. Let's look at example 2 and see also. Now example 2, we are still on subtraction of matrices. Let's look at example 2 also and see. We are still on subtraction of matrices. Now you can, let's say example 2. Now for example 2, you can also ask that given that B is given as 4, 2, 1, 3 and D is given as 0, 2, 0, 1. Then they will ask you to find, they will say find 2B minus D. Okay, and Roman 2, they will say find the transpose of D negative B. Let's look at it. This is very, very interesting question. Let's look at it under subtraction of matrices. Now for the fact that we are given B is giving us 4, 1, 2, 3, and C is also giving us 0, 0, 2, 1. Then we have to find 2B negative D, and we have to find D transpose minus B. It's very simple also. Let's look at it. Now, to find this one, we say the first one that we have to consider here is we have to find 2B minus D. But like we are not giving 2B first, let's try to find 2B and C. Finding 2B, we say 2 into, what is B? B is giving us 4, 2, 1, 3, negative D. And we know D is giving us 0, 0, 2, 1. Okay. Then after which, we are going to use this 2 to multiply these elements that are inside this bracket. Then if you do, we are going to say 2 times 4, we have 8. 2 times 2 giving you 4. 2 times 1 is 2. 2 times 3 giving you 6. Okay. After which, we subtract it with this one. We say 0, 0, 2, 1. Then subtracting this one, we are going to have, that is subtracting the first number with the first number. Then this one becomes, let's do it here and see what we are going to have at the end. We say 8 minus 0, we know it is 8. This one becomes 8. 2 minus 0, we know it is 2. 4 minus 2, it is 2. And 6 minus 1 giving you 5. So automatically, 2B minus D then becomes A225 as required. This is our answer for Roman 1. Let's look at the interesting one, that is Roman 2. We have to find D transpose negative B. Then to find this one, let's do it here and see. Now we have to find D transpose negative B. Now to find B transpose, we say D transpose negative B. But like in this case, we are not having the transpose of D. Let's try to find the transpose of D. Remember, we are giving D. Let's say this is our transpose of D. For the fact that we are giving D, remember, we just treated, it is among the types of matrices that I just explained. That is transpose of matrix. We are in the diagonals, the row, this row then becomes the columns, and the columns then becomes the row. That's what we call transpose of matrix. This row that you are seeing, then we are going to have 0, 0. They will switch on to row, to columns, and these columns we are going to have them as row. That is, we have 2, 1. Okay, this is the transpose of D. But like we are asked to subtract it with B, then we say 0, 0, 2, 1 negative B. But like we are giving B as 4, 1, 2, 3. We have 4, 1, 2, 3. Let's subtract and see. That is the first number with the first number, the second number with the second number. That's how we are going to do it. Okay, we say 0, negative 4. Okay, leave a space. Then we say 2 minus 2. Then we consider also this one. We say 0, negative 1, 0, negative 1. Then we are going to leave a space. Then we consider this also. Then we say 1, negative 3. Okay, now from this point, we just need to subtract for us to have our final answer. Then 0 minus 4, we know it is negative 4. 0 minus 1, it is minus 1. 2 minus 1, 2 minus 2, it is 0. And 1 minus 3 gives negative 2. So therefore, we can give our conclusion as the transpose of D negative B then becomes minus 4 minus 1, 0 minus 2 as required. Okay, this is for example 2 that we asked. Example 2 we just solved. Now let's try to look at another example for better understanding. Sometimes you can ask a question in the comment section. Okay, I will respond whenever I see your question in the comment section. Let's solve more examples on how to subtract matrices and see. Okay, now let's look at the 3 by 3 matrix. It's very, very interesting. Most of the students, they will ask them to subtract 2 by 2 matrix, then they will do, but like if they're asking them to solve 3 by 3 matrix, that one will be very, very challenging for them. Therefore, let's try to simplify it for everybody to understand better. Now, for instance, if you're having Z matrix as, let's look at this, 0, 1, 2, 3, negative 1, 1, 4, 2, 1. Then you are given W matrix as 1, 3, 2, 1, 4, 0, 1, 2, 3. Then let's look at it. This is very, very interesting, because then they will ask you to find Z minus W. Then let's say this is Roman 1 and Roman 2. Then they will ask you to find Z plus W. Let's look at this one. This is one of the most interesting problems, because sometimes students can't know how to solve 2 by 2 matrix, but whenever it comes to 3 by 3 matrix, it will be very, very challenging for them. Therefore, let's try to solve it for better understanding. This is 3 by 3 matrix. Why we refer this one to be 3 by 3 matrix? Simply because the row, we have the same number of rows as columns also. Sometimes we refer this one to be square matrix. Okay, now to subtract this matrix, to subtract this one, automatically we are going to say Z minus W. We are given the elements. We just need to write them. That is 0, 1, 2, 3, negative 1, 1, 4, 2, 1. We have to subtract it with W. W is given as 1, 3, 2. Then we say 1, 4, 0, and 1, 2, 3. Okay. Then from this point, like what we did by 2 by 2 matrix, we just need to subtract the corresponding terms, despite it is 2 by 2 matrix. Then we say the first number, let's subtract and see what we are going to have at the end. Then we say the first number with the first number, that is, we say 0, negative 1, 3, leave a space. Then we say 3, that is this, minus this next number, minus 1. Leave a space for this next number. We say 4, minus 1. We say 4, minus 1. Okay, this is 3 by 3 matrix, like I said. Then we move to the second row. 1 minus 3. We say 1 minus 3. Leave a space. We say negative 1 minus 4. The same thing, 2 minus 2. That is this 2. Then we move to the third row. We say 2 minus 2. Then we say 1 minus 0. Then 1 minus 3. Okay. Now from this point, we just need to simplify for us to have our final answer. Then if you have to simplify it, we say 0 minus 1, we know it is minus 1. Okay. 1 minus 3, it is negative 2. 2 minus 2, we know it is 0. Then 3 minus 1, it is 2. Minus 1 minus 4, giving you minus 5. Then 1 minus 0, it is 1. Okay. Then 4 minus 1, giving you 3. Then 2 minus 2, it is 0. Then the last one, 1 minus 3, giving negative 2. So this is our answer for Roman 1, because we have to find Z minus W. This is what we have. That is negative 1 minus 2, 0. 2 minus 5, 1, 3, 0, minus 2. Okay. Let's look at the next one. We have to add Z plus W. Now adding these two numbers, the same thing again, we add the corresponding terms. Okay. Now let's try to do it here and see. To add the corresponding terms, we say it is very, very interesting also, but like, let's just try to do it and see. Now we say let's add, we are given Z plus W, but Z is given as, these are the elements of Z that we are given. Sometimes we refer them to be square matrix, because all the row and columns are the same. Therefore we say 0, 3, 4, 1 minus 1 minus 1, 2, 2, 1, 1. This is what we are given for Z. Let's look at W. Say plus. We know W is given as 1, 1, 1. We are given 3, 4, 2. And the next one we are given 2, 0, 3. Okay. Now to add this matrix, we are going to say, like what we are doing in addition of matrix, we add the first number with the first number, the second one with the second number. Then we say from this point, we are going to say 0, that's the first number with the first number, plus 1. We are going to leave a space for the second number, that is, we say 3 plus the second number, that is 1 also, plus, leave a space, we say 4 plus 1. Okay. Next, let's move to the second column and see. We have 1 plus the first number, that is 3, negative 1 plus 4, this 4. Then we say 2 plus 2. Okay, the next thing, let's move to the third column and see. Now we have 2 plus 2, then we say 1 plus 0, then we say 1 also plus 3. After which, we just need to add the corresponding terms for us to have our final answer. Now, adding these two numbers, then we are going to have, we say, this one becomes, 0 plus 1 is 1, we write it. 1 plus 3, we know it is 4. 2 plus 2, it is 4. Now, say 3 plus 1, giving you as 4. And minus 1 plus 4, it is 3. Then 1 plus 0, it is 1. And we have 4 plus 1 giving you as 5. 2 plus 2, it is 4. And 1 plus 3 giving you 4. Okay, so this is what we have for Z plus W. We have added the two matrices, which results us to 1 4 5 4 3 4 4 1 4. Automatically we refer this one to be 3 by 3 matrix, and at the same time it is square matrix also. Okay, now let's move to the next subtopic under matrix. Let's try to treat multiplication of matrix. How to multiply matrix of numbers whenever you are given 2 by 2 matrix, neither 3 by 3 matrix. Okay, let's try to look at. You can ask your question in the comment section. Okay, if you have any question to ask, you can write it in the comment section. I will try to look at it and respond where necessary. Now, for the fact that we want to look at how to multiply matrix, let's say this is how to multiply matrix. Multiplication of matrix. Let's say multiplication of matrix. Now, to multiply matrix, what I need to do here is, we say, for the fact that, let's say this is A, B, C, D, and multiplying by M, N, P, Q. Let's just understand this one, after which we are going to solve millions of examples to unlock how to multiply matrices. Now, if you're having something like this, these are letters, but let's try to understand them first before we look at numbers. Now, to multiply matrices, that is 2 by 2 matrix, what are we to do here is, we know these two letters, they are rows, okay, and these two letters also, they are columns. We are going to use them first to multiply. That is, we say, these columns multiply by the row first. That we say A multiplying by M, okay, plus we say C multiplying by N, C times N. Now we have used this row to multiply this column. After which, leave a space. We are going to use this row to multiply these columns also. Remember, we first use this row to multiply this column, which results us to this. Then now we are coming to use this same row to multiply this column. Then we say A times P, we say A times P, plus we say C times Q, C times Q. Okay, now for the fact that we have used this row to multiply this column and this other column, now we are coming to use this same row, this other row, to multiply this first column and the second column. Now we just need to apply what we just did here. We say B times M, we say B times M, plus D times N. Leave a space, then we consider the next one. Now, for the fact that we have used this row to multiply this column, now we are coming to use this same row to multiply this other column. We say B times P plus D times Q. Now, after which you can check if it is correct or it is in that order. You can check. We know, always check for the last numbers. This is M, this is also M. It is in line. This N, this is also N. Check P, it is in line. We have Q and Q also. So it means you are in the correct form for you to have your correct answer. But like in case if there are no the same as if this is, for instance, if this is n and we have m here, it means you need to check your work also. Now after which we multiplied, we say a times m, we know it is am, plus c times m, we have cn. We are going to leave a space for the next one, that is a times p, we have ap, plus c times q, we have cq. Now we move to the next one, we say b times m, we have bm, plus d times l, we have dn. Leave a space for the next one. We have b times p, we have bp, plus d times q, which is dq. Now for the fact that they are not the same from unlike terms algebra, for the fact that they are not the same, we cannot say am plus cn will give you something. They will never give you something because they are unlike terms, they are not having the same letters or variables. So we cannot say am plus cn, we can have am cn. It will never give you anything because they are unlike terms, and we know unlike terms, they are terms that we cannot add, subtract together. Okay, you can only multiply them, but like you cannot add, neither you subtract them together. Okay, you can only do that one whenever you have like terms. So therefore, for the fact that this is letters and they are unlike terms, we just need to stop from this point. Okay, now let's look at examples that are having numbers. Let's see what we are going to have. Now let's look at example 1 on how to multiply numbers. Now we have let's say example 1, we have 2103. Let's say this is P matrix, and you're having Q matrix as 4321. Now from this point, we have to multiply PQ. Okay, let's say this is Roman 1, and Roman 2, we have to multiply Q square. Let's look at this and try to solve how we are coming to arrive at this point. The first thing, we say PQ is giving us, for the fact that P is giving us 2103 and Q is giving us 210, Q is giving us 4321. Like what I just explained, we are going to use that principle for us to arrive at our answer. These two numbers that we are seeing, they are row. Then we are coming to use them. We are coming to use them to multiply these columns. That is, we say 2 times 4 plus the next number, we say 0 times 3. After which we are coming to leave a space. Then we multiply also. Since we have used these two numbers, that is these row numbers, to multiply the columns, now we are coming to use this column, this row also to multiply these columns. Leave a space, then we say 2 times 2, we say plus, and the next thing we say 0 times 1. After which we are coming to use this other row to multiply these columns. Now we say 1 multiplied by 2, 1 multiplied by 4, we say 1 times 4 plus 3 times 3. Now leave a space, then we consider, now we are coming to use these same numbers to multiply this other row, these columns. Now we say 1 times 2 plus, we say 3 times 1. Like I said, after you have multiplied these numbers, try to check first if they're in that order before you multiply it now. We know this is 4, this is also 4, it is in order. 3, 3, it is in order. 2, 2, it is in order. And 1, 1, it is in order. Therefore, you can proceed with your multiplication. Now we say 2 times 4 giving you 8 plus 0 times 3, it is 0. Leave a space for the next numbers. 2 times 1, it is 2 times 2, it is 4 plus 0 times 1, it is 0. Then we have, let's look at the other numbers. 1 times 4, it is 4 plus 3 times 3, it is 9. Leave a space for the next numbers. That is, we say 1 times 2 giving you 2 plus 3 times 1, it is 3. After which, we just need to multiply to add now, where necessary. Now we have 8 plus 0, it is 8. 4 plus 9 giving you 13. Okay. Then we say 4 plus 0, it is 4. And 2 plus 3, we know it is 5. So therefore, our answer for Roman 1, that is PQ, then becomes 8, 13, 4, 5 as required. This is what we are asked to solve for P and Q, which result to this. Okay, let's go to the next one, Roman 2. Roman 2, we are asked to find Q square. Most of you will say it is impossible, like it is possible for us to find Q square, because we are not having Q square here, but like we are coming to arrive at that answer. Now, let's try to solve it here and see. Now we say we have to find Q square. This is what we have to find, Q square. Just like in expanding bracket, if you have something like square, it means you have to expand that bracket twice. That is what we mean by square. That is, this one becomes Q times Q. Now, for the fact that we have Q times Q, then we automatically have this Q. Therefore, we are coming to multiply this Q twice. Then we say 4, 3, 2, 1, multiplying by the same number back, 4, 3, 2, 1. Others may intend to say Q square. They intend to say this one. Then they will square. 4 square giving you 16. 2 square giving you 4. 3 square giving you 9. And 1 square giving you 1. Some might decide to do it like this way. But let's look at the correct method. Okay. Now, like the same thing, we use this row to multiply the columns. Okay. Now, to use the row multiplying the columns, we say 4 times 4. After which, we use this other number, we say plus 2 times 3. Now, leave a space and consider this next number to this row columns. Then we have 4 times 2, we say plus, and 2 times 1. Okay. Now, after which we use this row again to multiply these columns. Then we say 3 times 4, we say 3 times 4 plus 1 times 3. Now you're going to leave a space also for the next row. 3 times 2 plus, we say 1 times 1. And after which we multiply. Let's multiply and see what we are coming to have. 4 times 4, we know it is 16 plus 2 times 3, we know it is 6. 3 times 4, it is 12. 1 times 3, it is 3. And 4 times 2, we say it is 8 plus 2 times 1, it is 2. Now the next one, we say 3 times 2, it is 6 plus 1 times 1, it is 1. Now, after which we just need to add these numbers where necessary. Therefore, we say 16 plus 6, we are going to have 22. 22. 12 plus 3, it is 15. And we have 8 plus 2 giving you 10. 6 plus 1, 7. So therefore, the matrix that we have to find, that is Q square, then becomes 22, 15, 10, and 7 respectively. This is what we have to find for Roman 2. Okay, so this is what we have for multiplication of matrix. You can ask your question in the comment section. Okay, now let's move to the next one, how to find the determinant of matrix whenever you are given determinant of matrix, because that one is very, very important also. Most of the students normally miss at that point. But like, let's try to solve it also for us to see. Now let's look at how to find the determinant of matrix. Remember, today we are coming to learn maybe everything on matrices. Just stay cool and watch. We are coming to look at the next subtopic on how to find the determinant of matrix. Now, let's just try to clean first the board Then after which we are coming to learn another beautiful subtopic. Now after which let's try to learn how to find the determinant of matrix. Let's see determinant. Determinant of matrix. Let's start with 2 by 2 matrix. 2 by 2 matrix. Let's start with this one. 2 by 2 matrix. Now to find the 2 by 2 matrix, it is very, very simple. Maybe after today, you can able to solve millions of examples, because after unlocking the secrets on how to solve the determinants of 2 by 2 and 3 by 3 matrix, you are going to solve millions of examples on how to go about this one. Now, for instance, let's say if you have A, B, C, D, let's look at this. Then you will ask you to find the determinant of this matrix. Remember, this is 2 by 2 matrix. Why it is called 2 by 2? Because you are given 2 rows and 2 columns also. Now to find the determinant of this matrix, what I need to do here is we multiply the diagonal. These two numbers, we call them the diagonals. We multiply, we say A times D minus non-diagonals. These other numbers that you are seeing, we call them non-diagonals. Remember, all these numbers or letters that you are seeing inside the brackets, we refer them as elements. They are called elements. Then B times C, say B times C. These numbers, we refer them to be, these are non-diagonals. We say non-diagonals. They are non-diagonals, and for this we call them diagonals. Remember, I treated one of the type of matrix which I refer it to be diagonal matrix. This is how it look like. It moved from this point, not this point. That's why this one is called non-diagonals. Now from this point, we multiply. We say A times D, this one becomes AD minus B times C, it is BC. Now for the fact that they are unlike terms, they are not having the same letters, we cannot say AD minus BC will give you something. They will never give you something. Remember what I told you about unlike terms. Unlike terms, they are letter or variable that you cannot add, neither subtract them together. For the fact that they are not having the same letters, you cannot say you can add or subtract them at the same time. Therefore, AD minus BC, they will never give you something. You can just start from this point as your answer, because they are unlike terms. Okay, now let's look at example 1 on how to solve 2 by 2 matrix. Thank God I have explained this one. This one we refer them to be diagonals, and this other one they are non-diagonal, because according to the test of matrix, we have diagonal matrix. This is how it moves from this point. Let me just remind you, if you have something like this, this is diagonal. That's why we consider this also to be diagonal. And this other one, they are non-diagonals. Okay, we multiply the diagonal minus non-diagonal. Let's look at example 1 and see. Let's say this is example 1. Now if you are given, we say given that, let's say given that P is given as 1023 and Q is given as 4121. Then they will ask you to find the determinant of P and determinant of Q. Let's look at this one. We have to find the determinant of P and the determinant of Q. Now to find this one, what I have to do here is, thank God we have learned how to find the determinant of 2 by 2 matrix using these letters. Explain it well. Then if you have any question to ask, you can submit it in the comment section. Then I will respond to it whenever I see your comment. Now to find the determinant of P, it's very simple. You cannot even take 5 seconds to find the determinant of P. We say solution. P we are given as 1023. To find the determinant of this, we say the diagonal minus non-diagonal. Okay, that is, we say 1 times 3 negative the non-diagonal, that is, we say 0 times 2. Now from this point, what I need to do here is we multiply now. We say 1 times 3, it is 3, minus 0 times 2, it is 0. Then therefore 3 minus 0, we say it is 3. So this is the determinant of P that we have to find. Let's look at the determinant of Q also and see. For Q, the same thing. We are given 4, 1, 2, 1. Now to find this one, the same thing, we say the diagonal minus non-diagonal. These two numbers are diagonals and this other one they are non-diagonals. Therefore, we say 4 times 1 negative 1 times 2. Therefore, if you are multiplying these numbers, we are going to have 4 times 1 giving you 4 minus 1 times 2 giving you 2. Therefore, 4 minus 2, we know it is 2. Therefore, the determinant of Q then becomes 2 respectively. Okay? Now, so this is how we are going to treat 2 by 2 matrix. Then if you have any question to ask, then you can ask it in the comment section like I said. I will respond to it whenever I see your comment. Okay? Now the next one, let's look at how to find 3 by 3 matrix. This is 2 by 2 matrix. Let's look at 3 by 3 matrix. Let's look at 3 by 3 matrix and see. Thank God we have learned 2 by 2 matrix. Let's look at 3 by 3 matrix. Now to find 3 by 3 matrix, we just need to apply the same thing. For instance, let's say this is 3 by 3 matrix. For instance, having A, B, C, we have D, E, F, G, H, I. This is 3 by 3 matrix. Now what I need to do here is, this is very, very different from 2 by 2 matrix. Remember, the strength of this one is, if this is the strength, we have plus, minus, plus. This is the strength that we are going to use. If you are taking this A outside, that is A, it means you have to ignore the row and the columns where this A belongs. Therefore, if you have to ignore this row and the columns, automatically what will remain is EH, FI will remain. Okay? Remember the strength after plus we consider negative. If you are taking B also, now you are taking B. If you are taking B, it means you have to ignore the row, meaning you have to ignore this number and this other one. Then you ignore also the columns where B belongs. If you do, what will remain is DG, FI will remain. The same thing, remember the strength after minus you have plus, say plus C. Taking this C outside, meaning you have to ignore the row and the columns where this C belongs, meaning you have to ignore these columns and this row where this C belongs. Then if you do, what will remain? It is DG, EH will remain. Okay? Now, from this point, we applied 2 by 2 matrix from this point. This is 2 by 2 matrix. We can say A into, we say E times I, we say E times I minus, we say that is non-diagonals, we say H times F. The same thing again, we say negative B, then multiplying by D times I, we say D times I negative non-diagonal, that is G times F. Okay, the same thing implies, we say plus C, the same thing, the diagonals minus non-diagonals, we say and D times H minus G times E. More like, for the fact that these are letters, if they are numbers, we should have multiplying them. Okay, anyway, let's just multiply and see. We have A into, we say E times I, we have EI minus H times F, we say this is HF minus, we have B into D times I, this is DI minus, we say this is minus C minus G times F, this is GF. Okay, next one, we look at this plus C, the same thing again, the same thing that we implemented here. Let's try to do it again. We say D times H, this one becomes the H, minus G times E becomes GE. But like for the fact that they are letters, we cannot say we subtract them. Remember what I told you about like terms. Like terms, you can only subtract, add them together if they are having the same letters. But like for the fact that they are not having the same letters, because this is EI and this is HF, they are not the same letters. They are having different variables. Therefore, we cannot say EI minus HF will give you something. They will never give you something. Therefore, we can stop from this point as our answer. For the fact that they are letters, we cannot say we subtract them. Now let's look at example 1 and see on how to treat 3 by 3 matrix. Okay, for the fact that I have explained on how to multiply 3 by 3 matrix, now let's try to look at examples. Like I said, if you have any question to ask, you can submit it in the comment section. Now let's look at 3 by 3 matrix. Let's say this is example 1. Having something like this is very, very interesting. 0, 1, 2, 0 minus 1, 2, 3, 4, 1. Most of the students, I posted this problem, most of the students didn't arrive at the correct answer simply because they are yet to understand the basic foundation on how to treat 3 by 3 matrix. But like, for the fact that I have explained on how to do 3 by 3 matrix, we are going to implement the same thing that we understood from this explanation on how to solve this example 1. Now, to solve this one, like I said, the first thing that you have to note here is we have the trend that you have to use. We have plus, minus, plus. Don't forget to use this trend. If you forget to use this trend, automatically you are not going to arrive at the correct answer. Now, the first thing, if you are taking this 0, let's take this 0 outside. That's the first step that you have to do. Taking this 0 outside, we have taken it outside. Now let's say guys what remains. Meaning taking 0 outside, it means you have to ignore the row and the columns where this 0 belongs. Meaning we have to ignore this row, we ignore also these columns. Then if you are ignoring them, what will remain? These are the numbers that will remain. Therefore, we write minus 1, 2, we write 4, 1. This is what will remain exactly. The same thing, if we are taking this other 0 outside, remember the trend after plus, we have negative 0. If you are taking 0 outside, this other 0, it means we have to ignore the row and the columns where this 0 belongs. Meaning we have to ignore these columns and this other row where this 0 belongs. Therefore, what will remain? We are going to have 1, 2, 4, 1. Okay. The same thing, if you are taking this 3 outside, plus 3, we have taken it outside, then what will remain here? Meaning we have to ignore this row and the columns where this 3 belongs. What will remain? You have 1, 2, negative 1, 2. This is what will remain exactly. The next step, here we apply 2 by 2 matrix like what I just explained in 2 by 2 matrices. To multiply this one, we have the diagonal minus non-diagonal. This is 0 into multiplying the diagonal minus non-diagonal. We say minus 1 times 1 minus 1 times 1 minus, that is the trend how we are doing 2 by 2 matrix. Non-diagonal, we say 2 times 4. Okay, therefore we subtract also 0 into the same thing. We say diagonals minus non-diagonals. 1 times 1, we say 1 times 1, negative, we say 2 times 4. Okay, the next thing we say plus 3. The same thing, the diagonals minus non-diagonals, we say 1 times 2 minus 1 times 2. Let's look at it. Then after which we just need to simplify for us to have our final answer. This is 0 into minus 1 times 1 is minus 1. I should have used the short method, but like let's just try to use this one for better understanding. Now we say minus 1 minus 2 times 4 giving us 8 minus 0. This minus 0. 1 times 1 we know it is 1. Negative 2 times 4 we know it is 8 also, plus 3. This plus 3. 1 times 2 we know it is 2. And minus minus we know it is plus. 1 times 2 giving us 2. Then let's simplify and see. We say 0 into, we know minus 1 minus 8, we are going to have minus 9. Because from basic identity we say whenever you have the same sign, we take one sign of them and add the numbers. That's what we know on basic identity. Minus 0 into 1 minus 8, we are going to have minus 7, plus 3 into 2 plus 2, we have 4. After which we multiplied, we say 0 times minus 9. We know whenever you are multiplying number by 0, automatically you are going to have 0. Minus, minus, we know it is plus. 0 times 7 is 0, plus 3 times 4, we know it is 12. Now adding these numbers, we say 0 plus 0 plus 12, you are going to have 12 respectively. So it means our determinant of this 3 by 3 matrix, for example 1, then becomes 12 respectively. This is what we have to find for example 1. Let's look at example 2 and see. Let's try to solve series of examples for better understanding, because this is one of the key subtopics that normally disturb students in exams. Most of the students find it very, very difficult to find the determinant of 3 by 3 matrix. Even though some can do 2 by 2 matrix, but like when it comes to 3 by 3 matrix, it will be very, very challenging for them. Therefore, let's solve more examples on how to solve 3 by 3 determinants. Now let's look at next example and see what we are coming to have also. Like I said, if you have any question to ask, you can submit it in the comment section. And let's look at the next example. Now we say the next example, if you're having, let's say this is example 2, then given that, or maybe they will say find the determinant. They will say find the determinant of the matrix. This is the matrix now that we are given: 0, 1, 2, 3, 4, 1, minus 1, 2, 1, 3. They will ask you to find the determinant of this one. It's very, very simple. Like I said, most of the students can do 2 by 2 matrix, but like when it comes to 3 by 3 matrix, they will find very, very difficult and challenging to them. So therefore, we can try to solve more examples to unlock the secret on how to solve 3 by 3 determinant. Now, like I said, the first thing that you have to do here is, if you are taking this 0 outside, remember this is the trend that you have to follow: plus, minus, plus. We know this first number, it is carrying plus. We say 0. Now if you are taking 0, it means you have to ignore the row and the columns where this 0 belongs. Meaning you have to ignore this row and these columns where this 0 belongs. If you do, these are the numbers that you are going to see only. That is 4, minus 1, 1, 3. This is what you are going to see. Don't forget the trend. We have the next one should be negative 3. After which, if you are taking 0, also, if you are taking this 3 outside, like what I just did, it means you have to ignore this row and these columns, the row and the columns where this 3 belongs. If you do, the number that you are coming, you have to see here is 1, 2, 1, 3. Plus, don't forget the trend. We say plus 2, the next number. If you are taking this number outside also, it means you have to ignore these columns and the row where these 2 belongs. Therefore, what number that you are going to see here is, these are the numbers that you are going to have now. That is 1, 2, 4, minus 1. Now, for the fact that these are 2 by 2 matrix and most of the students, 99% of the students can solve 2 by 2 matrix. Therefore, we can say this is 0 into, we multiply diagonal minus 1 diagonal. That is 4 times, say 4 times 3 minus, say minus 1 times, minus 1 times 1. The same thing, we take this one, we say minus 3 into 1 times 3, say 1 times 3 minus non-diagonal, that is 2 times 1. Okay. The next thing, we say plus 2 into 1 times negative 1 minus 2 times 4. Okay. Now from this, we have, let's try to simplify it for us to have our final answer. Now we have 0 into 4 times 3, we know it is 12, minus, you know, minus minus giving us plus. 1 times 1 is 1, minus 3 into 1 times 3, we know it is 3, minus 2 times 1 is 2. Don't forget. We move to the next one. We say plus 2 into 1 times negative 1 is negative 1, negative 8. Then the next step, we say 0 into 12 plus 1. This one becomes 12 plus minus 3 into 3 minus 1. 3 minus 2 giving you 1 plus 2 into negative 1 minus 8 giving you negative 9. For this one, your final answer, you just need to multiply these numbers. Automatically having these numbers, this one becomes 13. Remember, 12 plus 1 it is 13. Then multiply this number, 0 times 13, it is 0. Minus 3 times 1 it is 3. And plus times minus is minus 2 times 9 giving you 18. Now adding these three numbers, automatically you are going to have 0 minus 3 minus 18. This one becomes 2 minus 21. Therefore, the determinant for example 2 then becomes negative minus 21. Okay, so this is example 2 on how to find 3 by 3 determinant. Now let's look at the next one. This is another subtopic. Let's look at the next subtopic on matrices. Like I said, if you have any question to ask, I will respond it in the comment section. Just ask and leave it in the comment section. I will respond. Let's look at the next subtopic. Let's look at the next subtopic and see. Let's look at simultaneous equations. Okay. Now let's look at how to find the inverse. Let's look at how to find the inverse of. This is the inverse of 2 by 2 matrix. Let's look at the inverse on how to find 2 by 2 matrix. We say the inverse. Let's look at the inverse on how to find 2 by 2 matrix. Now, it's also simple. Let me just explain it. If you have something like this, 2, 1, 3 minus 1. Then they will ask you to find, let's say this is A is equal. Then they will say find the inverse of A. This is how we are going to see it, the inverse of A. It's very, very simple. The first thing that you are coming to do here is, we say, let's find first the determinant of this matrix. Find the determinant. That if you have 2, 3, 1 minus 1. Find the determinant of this one. Then we are going to, like what we did, we say diagonal minus non-diagonal. This one becomes 2 times minus 1 minus 3 times 1. Then we say minus 2 times minus 1 giving you minus 2 minus 3 times 1. This one becomes 3. Therefore, this one becomes minus 5. That's the first thing that you have to do in finding the inverse of any letter. Okay. Now, after which, what I have to do here is, remember, let's just try to exchange these numbers, meaning, and these numbers, we are going to exchange this. Remember, this is diagonals, and these are non-diagonals. Now, here, we exchange the numbers in their various positions, and here we change their signs. Now, we say, instead of these two, we have now 1, minus 1, 2. We exchange the numbers. And for these non-diagonals, we just need to change their signs. But these numbers may stand where they are. We just need to, see, for the fact that this is plus, this one becomes negative 1. This is negative 3. Okay? After which, we divide by the determinant that we just have, negative 5. Okay? Now, from this point, what we need to do here is, we find also, we use this negative 5 to divide throughout by these numbers. Automatically, we say minus 1 divided by minus 5. We say minus 1 divided by minus 5. We say minus 3 divided by minus 5. And we have 2 divided by minus 5. After which, then we say the determinant of A, the inverse of A then becomes, this minus cancels this other minus. We have 1 upon 5. And we have 1 upon 5 also. 3 upon 5. This one becomes 3 upon 5. and we have 2 upon this minus 2 upon 5. So therefore, the inverse of this matrix then becomes 1 upon 5, 3 upon 5, 1 upon 5, and negative 2 upon 5. Okay, thank you for watching. Make sure you share for others to benefit. Okay.